That's the impression that I get. Okay, we're live again. So, electrolytes. What is an electrolyte? Is this going to work? Yes. Oh, no, you can't hear it. No, don't. Okay, well, just look up this video. Oh, that's a shame. Why wasn't it working, I wonder? All right, well, anyway, they talk a lot about electrolytes. And then at the end, he asks, what are electrolytes? It's not a great movie. It's very bigoted in some whatever. All right, so what are electrolytes? They're salts. Water doesn't conduct electricity. Pure water, all by itself, will not conduct electricity. But if you add something to the water, if you dissolve something in the water, and it then starts to conduct electricity, then the thing you've added is an electrolyte. Okay? An electrolyte is something that you dissolve it in water and it permits the conduction of electricity. So there are strong electrolytes, weak electrolytes, and non-electrolytes. Strong electrolytes make water conduct really well. Weak electrolytes make it conduct, but not that well. Non-electrolytes do not let water conduct electricity. So, strong electrolytes make lots of ions in solution. So, a salt, you dissolve it in water, they dissociate 100%, meaning that they break up entirely into ions. So that looks like this. For example, sodium chloride is really good at dissolving in water. NaCl. You dissolve it in water, you end up with Na plus Aq plus Cl minus Aq. Okay, so this is an example of, it looks exactly like a chemical reaction, and it kind of is, but what it represents is you're taking the solid, you're throwing it into water, and it dissolves. Okay? And it does that 100%. This is called dissociation. Association is when things come together to make an association. Dissociation is when things split apart. Okay? But you got to pay attention. You got to be careful when doing this sort of thing. Let's look at potassium sulfate. Okay. When asked to write this out for the first time, I've seen a lot of weird stuff. Remember, potassium, it's a simple monatomic ion. So when it dissociates, they're going to break up, and you're going to get two of them. Each one is going to have a 1 plus charge. Okay. Remember, potassium is in the first column of the periodic table, all the way over on the left. So when it forms an ion, it takes a 1 plus charge. All right, so that is Aq. And then, of course, sulfate is a polyatomic ion, so it's just SO4 2 minus. Okay, so be aware that, they break up into their individual ions. If there's more than one of that ion in the formula unit, then you're going to get more than one of them floating around in solution. Okay, let's see if I can't come up with another good one. Let's pretend this one will dissolve in water. Okay, no, let's not do it. Yeah, here we go. There we go, even better. Aluminum carbonate. I'm pretty sure this is not soluble in water, but we'll pretend for the moment. So you're going to get two aluminum ions, each one with a 3 plus charge. Remember, aluminum is one of those ones in the middle of the periodic table. It's on that stair step, silver, zinc, aluminum. Things never go away. They just come back in a different form. And then we're going to get 3 of our carbonates, each one with a 2 minus charge. Okay, so this is where you're going to get more practice with your ions, more practice with your salts. And just be aware of what your polyatomic ions are, because the carbonate's not going to break up into carbon and oxygen. It's going to stay as carbonate. All right. So, meanwhile, we have strong acids. These are the strong acids you're going to need to know. Hydrochloric acid, hydrobromic acid, hydroiodic acid, then nitric acid, sulfuric acid, and perchloric acid. Acids, they look very similar to salts in that they will also split up into ions, but they're not ionic compounds. So we can't say that they're ionizing. Well, at least we don't say that they're ionizing. Instead, or we can't say that they're dissociating, it's breaking up into the ions that are already there. Instead, we say that they're ionizing. Because they're going from a non-ionic compound into ionic forms when you dissolve them in water. So hydrogen chloride, okay, HCl, you drop it in water, it will ionize 100%. Okay. So this looks a very, very great deal like the salts do. But these aren't salts. They're acids. So we call it ionization. So every ionic compound, every salt, is a nice strong electrolyte because they all dissociate 100%, insofar as they dissolve in water. If they dissolve in water, then they also dissociate. Okay? That is what dissolving means for an ionic compound, is that it would dissociate. But not all covalent compounds ionize. Okay? So strong acids ionize 100%. That is, when you look at this reaction over here, every single molecule of hydrogen chloride breaks up into H plus and Cl minus. And that's what it means to be a strong acid. Now, we also have weak electrolytes. Okay? These make only a few ions in solution. Okay? That is to say, when you dissolve them, they don't make a lot of ions. Okay? So, weak acids and molecular bases. Okay? A weak acid is any acid that isn't strong. Okay? So, for example, if it's not one of those 7 on the list, then it's a weak acid. But our old friend, vinegar, HC2H3O2, it is a weak acid. You dissolve it in water, you will get H plus C2H3O2 minus. Okay? It will dissolve. It will dissolve completely, in fact, but it won't ionize completely. Okay? So you'll get this mixture floating around in solution of H plus, C2H3O2, okay, it's there, O2 minus, and HC2H3O2. All of them dissolved in water, but it doesn't break apart completely. Describing that, the fact that they don't break up completely, is a big part of learning about acids and bases, and it's a section unto itself in the second semester. As for molecular bases, this means any base that isn't an ionic compound. So the big example there is going to be ammonia. Okay? You dissolve ammonia in water, and what happens is it reacts with the water. So aqueous ammonia, liquid water, you get this reaction, NH4 plus OH minus. Okay? So again, it's ionization, but again, not 100%. Okay? This is related to the weak acids sort of thing, that this ionization occurs, but it doesn't occur at 100%. So there are a lot of compounds that will do this sort of thing. They are not salts, they're covalent compounds, hence I call them molecular bases. That's to distinguish them from, say, sodium hydroxide or potassium hydroxide or iron 3 hydroxide. Those salts, those hydroxide compounds, those are your strong bases. So like I said, most of the things, my dog is right behind me. All right. That do this are nitrogen-containing compounds. So, for example, you have methyl ammonia or aminomethane, which looks like this. You mix it with water, then not 100%, it will make CH3NH3 plus OH minus. Okay, looks very, very similar. You can also have pyridine, which is an organic compound where you have nitrogen as a member of a ring with a whole bunch of carbons. And again, you mix that with water, and you can get, I think it's called pyridinium. Um, and again, it'll do the exact same thing. They all have this exact same behavior. They react with water. They take a proton from hydrogen. They make this positively charged compound and OH minus. So anything that looks like this will do that. There's it pretty much effectively, thanks to organic chemistry, an infinite variety of these. Ammonia is the big one. Okay, it is going to be a weak base. It's going to be a molecular base. It is also a weak electrolyte, okay, because they all do this sort of thing, but they don't do it 100%. You'll still have this guy floating around in solution as well as some of this guy. All right. Finally, non-electrolytes. A non-electrolyte produces no ions when you dissolve it in water. So all other covalent compounds are non-electrolytes. CO2, sugar, oxygen, all non-electrolytes. Okay. So there's a table on page 238 of your textbook that sort of explains this, shows you a bit of that. Now, there's also a way that I like to draw it. Let's see, do I have... No, let's bring up the camera. All right, so... Okay, so is it an ionic or is it a covalent compound? If it's an ionic compound, it will automatically, more or less automatically, be a strong electrolyte. Now, if it's a covalent compound, then it could be a strong acid, a weak acid or molecular base, or it could be other. Neither an acid nor a base. If it's neither an acid nor a base, it's a non-electrolyte. If it's a weak acid or a molecular base, it is a weak electrolyte. And if it's a strong acid, it's a strong electrolyte. All right, so that's one way of representing it, sort of picture format. I have also been slowly trying to bring up the textbook so that I can show you the table on page 238. There we go. I'm getting there. I'm getting there. It's taking a minute, but I'm getting there. All right, viewing the e-text. So now, instead of just listening to me wait, you can watch and wait with me. This is okay. Textbook is blue. This is not the first time I've opened the textbook in here. Come on. All right, so here's the table. So strong electrolytes, it shows you all the strong acids. It shows you a few of the strong bases. And then it says other soluble ionic compounds. Like I said, we'll go into solubility rules when we start talking about precipitation reactions. Then weak electrolytes, we have a weak acid, another weak acid, another weak acid, but they don't mention ammonia for some reason. And finally, non-electrolytes, water, alcohols, sugars, pretty much every organic compound. there's caveats there. Some organic compounds can be weak acids or weak bases, but you will learn to recognize some of those. So, like I said in the thing, I don't know what they will expect you to know, but learn to recognize the strong acids. Learn to recognize other acids. Learn to recognize bases. And then just recognize that all salts are going to be strong electrolytes. All other covalent compounds will be non-electrolytes. All right, so that does it for what electrolytes are. I will see you in a few minutes to talk about precipitation reactions, putting together the net ionic equation.